All right, here we're going to derive the buoyancy equation of rho of the fluid, the volume of the fluid displaced, times the acceleration due to gravity, or the gravitational field strength. Here, buoyancy force. We want to derive this equation. Turns out, a couple of things you have to remember. First, you want to remember pressure is force per unit area. We can easily rewrite this equation as force equals pressure times area. That's important. Turns out the buoyancy force is a result of difference in pressure. The buoyancy force is a result of the difference in pressure times the area. If we look at this block that's submerged in a tank of water, right? All the molecules up here might bump into the top here, and they're going to push down with so much force, right? Pressure is a result of molecules bumping into the surface. So they're pushing down there. The molecules underneath are also bumping into the surface down here, right? That side. But because they're deeper, right? Remember, pressure, gauge pressure is rho g h, where h is kind of the depth. So this depth is not so great, so that's a small arrow. The bottom of the cube is deeper, so it's going to get the molecules there are hitting with a greater force up. Now the molecules on the side are also bumping into it, and as you go deeper and deeper, the arrows will be getting longer and longer. The arrows on the bottom are going to be the longest. Should be the longest because they're the greatest. But then there's going to be arrows on this side, molecules hitting there. All the left and right arrows cancel each other out. The top and bottom arrows end up with a net force up, and they result from a change in pressure. The change in pressure at the top on this surface compared to the change in pressure on that bottom surface. So the buoyant force is a result of this change in pressure, the gauge pressure, right? The change in pressure is rho g delta h times a. There's that delta h. Now, let's look at this. What is a change in height times an area? An area, meters squared times another meter. That's cubic meters. That's volume. So you get the force, the buoyant force, the net force is up, is rho g volume. Rearranging the letters, the force buoyant is rho v g. This is how we typically write it. But there's the derivation of the buoyancy equation. And it results from a difference in pressure. The pressure on the top of a cube is pushing down is less than the pressure from the bottom of the cube pushing up, and all the pressures on the side cancel out.